Hi, I'm Derek from Good Times Marine. Today we're privileged to meet with Steve Miller. He's the head of, well, give me a title.
Well, they call me the senior category manager at Mercury Marine. I'm not sure if that's just because I'm just old or I've been around long enough, that's all.
There you go. This gentleman knows a heck of a lot about outboards, and in particular, today we're having a look at this new product from Mercury, which ranges from 75 horsepower all the way through to 115. It also has a few different gearboxes that you can mix in there as well. Is that right?
Yeah, we're really excited about this new offering, and we've focused on a number of things with it. One of it is improving the displacement, highest class displacement at 2.1 liters. Lightest weight package. The 115 is the lightest weight 115 on the planet, 163 kilos. And what's more important is how can we take all of that displacement and that lightweight, take advantage of it, and really make it something that's versatile enough not just to run on light boats, but even heavier boats as well. And that's where we realized, we could do something nobody else in the industry's done so far, and that's take two different gear case offerings into the 90 and 115 class of engines. So we have our standard gear case models, which is a new standard gear case with 15% less hydrodynamic drag than the prior Gen 4-stroke we had. For the smaller, lighter boats, really nice, fast gear case, very efficient, helps us make some great fuel economy numbers. Or for boats that tend to run wetter, so in other words, once you plane off, you still got a lot of hull in contact with the water. Boats like that can benefit from the lift of a bigger gear case. And so we have our new command thrust models. So that's basically taking the gear housing from our bigger 150 horse 4-stroke down to a 115 and a 90, putting a new gear ratio in, almost a 2.4 to 1 gear ratio. And that also gives you access in a 90 and 115 class product to our V6 range of propellers, which is a much bigger diameter, bigger blade area range of propellers like our popular Inertia series. Mm-hmm. So you take that 115 with that big 2.1 liters of displacement, give yourself a nice big gear case so you've got a lot of leverage in the water and the thrust of a big diameter propeller, and you can really get a much bigger, heavier boat up on plane quickly, give it better mid-range acceleration, hold it on plane at lower speeds. And what's really nice is you've got right and left-hand rotation options, so if you want to expand to a dual engine offering with counter rotation, you can do that as well.
So if I'm correct in this, what you're calling the command thrust, the big gearbox, is only available in the 115 and the 90, is that right?
That's correct, yep.
Now, if I was a greedy man and I was like, okay, cool, got my boat and it holds a 115, I'm automatically going to go to the command thrust. Is that always the case? You can get that little bit more punch, so you automatically go straight to the command thrust, or is there a reason for going to the command thrust?
Yeah, one of the things we realized a long time ago is you really can't take a one-size-fits-all approach to gear case design, especially in this range of horsepower, which has to serve on so many different kinds of boats. So what we've realized is that a standard gear case model is still going to be the best choice for certain boat applications. So a good rule of thumb for me was when I think about aluminum fish boats or saltwater fiberglass fish boats, 5.5 meters or below, I still think the standard gear case is a better choice there. In a smaller, lighter boat like that has a lot of its own natural lift, a command thrust in that case could actually overlift the boat, create handling issues that you maybe don't want. That gear case, that bigger command thrust, is really designed for boats over that 5.5 meter mark, or occasionally boats that are smaller but run really wet when they're planed off. Okay. Real heavily loaded boats, things like that just really need some extra leverage in the water to lift them properly. Okay. So you really can't take that one-size-fits-all approach. You got to look at it by boat type and really pick the best option for that boat.
Engines seem to have come a long way when it comes to use in salt water. Obviously, the older engines, there's always talk about corrosion in the motor. You pull the cowl off and there's just salt there and you don't even know where it even came from. Mercury's always been known for really pushing hard against that with this new engine. Have you come up with any new developments to improve with saltwater use and preventing corrosion?
Well, that's a good question. These engines have the same arsenal of corrosion protection tactics that we use on our larger engines, so we don't start removing corrosion features when you start going down in horsepower. I think one of the things we focused on a lot with these engines is cowl sealing. And that's always your first line of defense, right, is to try to keep the power head as dry as possible. Now, you'll never keep all the salt out just because there's salt that's in the air itself that enters in there. Yeah. And, so you're always going to have some salt. But we've got a very nice cowl system. It's got a big seal on it with an anti-friction coating on it, so it's still easy to take on or take off and put on. but it really seals out that salt water. And it's got a baffling system in it, which does a nice job when you take a bunch of salt water in through the intakes on the cowl. It separates the water out and redirects it back out through the cowl, through some drains in the back, and just lets that nice pure air enter in where the engine is. So I think, that's one thing we do. And then, of course, we have better base alloys, which we formulate by ourselves with our own Mercury metallurgists, which have much lower copper content than all of the competition does. And so we've got a good base alloy to start with. We've got great treatment processes with the alloys. We do an electrodeposition priming process that paints not just the outside of the casting, but inside as well in the cooling passages, and actually electronically bonds the paint to the metal. So it's a great corrosion protection strategy. All of our electrical components are triple O-ring sealed. We really pull out all the stops to make sure that we can fight salt water better than anybody else.
Yeah, it's fantastic. I noticed that you've got a big range of horsepower available from the one engine. Mm-hmm. Someone who's looking at 75 horsepower or someone who's looking at 115 horsepower, I can expect to be asked the question, how can you have such a broad range out of one engine? What are the things you do to compensate with that or create the extra horsepower out of the same engine?
Well, we like a single platform strategy like this for a lot of reasons. A lot of our competition will try to cover this range with two platforms. Mm-hmm. What we like to really strive for is power to weight. And so, if all we focus on is exclusively as a weight, we can wind up with engines that are much lighter, but we're going to have to sacrifice displacement and boat performance and fuel efficiency. We're going to have to push the engine harder, which taxes it more, makes it less durable on the low end in order to do that with a small platform. With a bigger engine displacement and better power to weight ratio, we can be competitive in weight, but we've got a better displacement as well. So we've got better boat performance, we've got better fuel efficiency, and more durability because the engine doesn't work as hard in the low end of the power band. So we like that strategy a lot. It works pretty well for us. And even at a 115 level, this thing shares the same architecture as our 150 four-stroke. Okay. So it's going to be a very low stress, high displacement, very durable package that covers a broad range of horsepowers.
Last question. A mechanic friend of mine always tells me that the bigger the displacement of the engine, the better the engine's going to perform with regards to torque, and focus less on the horsepower. It's all about the displacement you can get in that horsepower. Is there a specific reason why you've gone for such a big displacement engine? I mean, I'm sure you could have probably created horsepower out of a slightly smaller displacement, do you think?
Sure. You could go with lower displacement designs, and you can create, if you just want to hit a horsepower target at the end, you can turn the engine at a faster engine speed, RPM, and achieve a horsepower target. But, what we've learned is that maximizing displacement really improves the quality of the torque curve at the bottom end. And what more often than not our customers tell us is they want strong acceleration, they want good mid-range punch, they don't want the boat to be pointing at the sky for a long time when they're trying to plane off because it obstructs your visibility. They want to be able to hold the boat on plane at lower speed. All of those wants and needs are delivered through an engine that has a very fat, strong torque curve at the bottom end. And to do that, you really need to have the displacement there. The other byproduct of that displacement with a power output in the 90, 115, 75 range is the engine doesn't have to work very hard to develop that torque and power. So it's a very low stress engine with a very big torque curve that meets all those acceleration goals of the consumer. Okay. And you're not going to make a trade-off in top speed or weight when you go with the Mercury product to get there.
You must be a very proud man.
I'm very excited.
Put a fair bit of time into designing it and to see it all finished here, and it looks absolutely fantastic.
Well, thank you very much. This is the best part of my job, getting to share it with the world.
You've done a good job.
Thank you very much.
Thank you, Steve. Nice to meet you.
Nice meeting you.
We'll speak to you again soon.